Hi, everyone. Thanks for joining. I'm Cole Murray, and today I'll be giving a talk on building a company internal background agent system. A bit about me. My day to day, I work as a consultant for seed and Series A startups, primarily building AI based systems. Everything from voice agents to coding systems, and more recently, background agent systems. And so, why this talk? Over the past few months, we've seen several blog posts come out from companies such as Ramp, Stripe, Coinbase, outlining a system that they've built that is increasingly taking over more of their pull request count. With this, we've seen that most teams want background agent systems, but not all of them know where to start and what are the challenges that they will face when they begin. And so today, I'm going to be covering the architecture, the use cases, and some learnings that I've had across my clients and issues they've run into. And so before we jump in, we need to understand what is the problem with localhost and what are we trying to solve. Today, most of the coding agents is being done on localhost, where we have one agent running on one machine. Within that session, the agent is handling the linting and testing. It's handling the compiling of the changes. If the company uses microservices, it's often running Docker Compose, which has the Postgres, the backend, as well as many other systems. And then the developer is running their own dev server. As the developer becomes more proficient with AI, the number of sessions that they are running simultaneously grows. Often this is up to 4 to 5 simultaneously, but in some cases it is much higher. And so we begin to see a challenge where the number of sessions is continuing to increase, but the amount of resources within that machine is not increasing. And so it begins to break down. We only have so much CPU and RAM available, as well as we start facing a problem with how we actually perform that work. And so most commonly, engineers are using a technology called Git work trees. The general idea of a work tree is that we will create parallel copies of the GitHub repo such that we can operate on them without any conflicts. Now, this works great, but each of those copies requires its own independent set of resources to maintain true isolation. Similarly, an issue where we're seeing localhost begin to break down is with non-engineers. As the coding agents have become quite proficient, we're seeing contributions into the code base from PMs, CEOs, as well as support agents. Not only is it risky to have the non-engineers setting up this stack, but it's also very cumbersome because it requires them to maintain this over time, and this isn't their expertise of where they operate in. And so if we look forward where we see that the session count is going to continue to grow, we're going to have an ever increasing problem where the resources of our machine are just not going to be able to handle this load. And so unless your plan is to have a supercomputer underneath your desk, we're going to have to find a different way to solve this problem. While all of this is going on, we're also seeing a shift between how code is being written. Engineers are no longer writing code by hand, but instead autonomously driving agents to deliver this code. As this shift plays out, the role of the engineer is shifting. We are shifting from a software engineering world to what I describe as software manufacturing. In the old world, an engineer could be seen as an artisan. They were handcrafting their code. The quality of that code heavily relied on who was actually crafting it. And really, they were kind of working on one primary task at a time. As the agents are becoming more capable, we're seeing a shift away where engineers are acting more as production line managers. And so we need to start building infrastructure that models this changing world. And what that looks like is basically a production line, which is a fleet of background agents, which are then building and delivering our artifacts. We need to have quality control on that so that each artifact that is produced matches the same quality specifications. And finally, we need to have some type of review loop. Inevitably, we will have defects that end up in production. And so we need a system that not only fixes those defects, but identifies the root cause and fixes it within the production line. And so now that we have kind of an idea on the problems that localhost is causing, we're going to chat through some of the benefits of a background agent system and what people are doing with it. Across the many deployments that I've done with my clients, I see a few reoccurring use cases. The first is SRE type workflows. Teams using this, whether it's to add context, whether it's to actually root cause and triage the issues, but in general, just using a background agent as the first responder of a support issue. Next is customer support. Previously, where a customer support agent might have to wait to escalate to engineering, they are now often able to root cause those issues by themselves. As mentioned previously, we're starting to see a shift in who is contributing code. We're starting to see PMs contributing code and able to deliver on their own product specifications. Another very common use case that we see is self-serve data and business analytics. Rather than having to wait on a dashboard to be built or waiting for a data analyst to respond, teams are using the background agent to actually go and fetch this data out of their production systems. Last, we see a lot of use cases where teams are using it for rapid prototyping, and discussions are moving away from being centered on a doc to being centered around a demo and driving consensus through that. And so focusing a bit more on the SRE use case, we are seeing a lot of cases where the alerts are able to be automatically triaged by the team. In the previous world, a team would get a page, they would wake up, the engineer would then begin tracing through production logs and recent commits and trying to find out basically what went wrong. With a always-on background agent system, we can cut out a lot of that process and have the agent actually respond the moment that that alert goes off. Because it's integrated into all of the company infrastructure, it has access to the logs, the knowledge base, the GitHub repo for the commits. And so we're able to basically create a root cause analysis before the engineer even jumps into the issue. In a lot of cases, we can not only identify what the issue is, but also fix the issue and create a pull request. Because again, the agent is hooked into your code base, it knows the existing patterns and can create a pull request that actually resolves the issue before an engineer even shows up. The next use case we're seeing a lot of is customer support. As mentioned previously, customer support for anything technical often would have to either escalate to a technical support agent or in smaller companies be forced to wait for an engineer within the company to look further into this. This has created a pretty big shift because now not only are we resolving our tickets faster because the support agent can self-resolve these issues, but we're also seeing better quality of things that do end up escalating to the team because the agent has already collected all of this context and the support agent is able to better describe what is happening. With PMs, in the old world, a lot of times a PM would identify an issue. They would then file a ticket for that and be waiting for engineer to then action on top of that. Similarly, they would create a specification. They would take 2 to 3 weeks to create this and then hand it off to engineering. We're starting to see that change with background agent systems because we've removed a lot of the friction of setting up the environment and the coding agents are able to deliver high quality pull requests. The PM no longer needs to wait to have their code changes. They're able to directly prompt the background agent and have a pull request created for this. Engineering is still in the loop here. They're still signing off on the pull requests, but the time to that resolution has drastically reduced. Previously, a lot of teams had to wait for data. There was most commonly a team who was kind of responsible for data warehousing. They maintained the fax tables, and if you wanted access to the data, you would file a ticket, and they would build you a dashboard that answers your various use cases. That world has changed a lot with background agents. I see a lot of teams who are now using them to be able to directly answer the queries that they have without needing to involve a data analyst. And this is huge because now everyone at the company can get better insights on what's happening, whether that's understanding a A/B test that they're running, whether it's just general usage metrics. How many people have called into the phone lines this week? How many calls were escalated? A lot of those questions previously were just locked behind a engineer resource being able to address them. But with a background agent system, the agent is actually able to address the majority of these questions. And so, lastly, we're seeing a consensus before the PRD. Previously, stakeholders, we would argue about a paragraph, we would go back and forth. The engineering team would kind of argue that there's limitations, we can't do this, we can't do that. With background agents, because it can build on top of the existing code base, a PM or whoever is responsible for this can actually come with a prototype that is roughly 80% of their idea. And rather than discussing over a document, we can form consensus about a demo and whether it aligns with something that we want to build rather than what to build. Now that we've covered some use cases, we are going to jump into the architecture behind OpenInspect. The goal here being not so much for OpenInspect, but just the general patterns that we see across background agent systems. OpenInspect is an open source background agent platform. It is modeled after Ramp's internal inspect system, which they published a blog post about. It is completely open source. You can fork it, you can modify it however you please, and really customize it to your company's internal services and conventions. The system, the control plane is built on Cloudflare. The sandboxes run in Modal and more recently as well as Daytona. The agent itself is using open code, so similarly there you can modify it however you'd like. And lastly, there's many surfaces where the agent can be used, ranging from web, Slack, linear, there's webhooks, there's automations, and the general idea being that you can build a client for that agent to meet you wherever work is already happening. The pattern that we see across OpenInspect, as well as all of these other systems that we see in blog posts, is this idea separating the control plane and the data plane. Our control plane is generally capturing and handling coordination. It's capturing the state, the identity of the system, the secrets, and it is then dispatching all of this into a sandbox. Now, there's a bit of discussion on whether the agent should run in the box or out of the box. I'll leave that as an exercise for you guys to explore. But the general idea is that you have the execution of the agent, its commands that are being run in a sandbox that is isolated. This sandbox is a perfect replication of your developer environment. And so all of those services that we described that are running on localhost, these are perfectly replicated within the sandbox. And so with that, we get a lot of benefits. When running an agent on localhost, the environment may be in different states at any given time. There may be commits outstanding, documents left in the repo, dependencies installed with different versions. With a sandbox, the environment is perfect every time. And that's a huge advantage for agent reproducibility because we know that everything will be in the perfect state when that agent runs. Similarly, we don't have to worry about any long-running issues with the agent because that environment is disposable. And so we get some cool benefits here where we can run multiple versions of the same prompt in parallel and then compare the outputs with that, as well as just generally being able to stop and pause and restore without needing to shut down the system. We've seen a lot of kind of funny making fun of localhost where teams are keeping their laptops open and Basically, because it is stuck on localhost, they don't want to shut down the machine. That's no longer an issue with a background agent system. A common complaint that I see people who are not familiar with background agents is the concern over the boot time of the sandbox. It's a very common question of how long does it take for the agent to actually get running? Across most of the sandbox providers, the boot time is typically under 2 seconds. And so the next question then is, what is the actual long pull for that first token to arrive? Without doing clever tricks, a lot of time is going to be spent installing the dependencies, setting up those databases we talked about, and generally replicating that environment. And that can be quite time consuming. Now, a clever trick that we see across many different of these described background agent systems is this idea of a warm start. Because we know the developer environment ahead of time, we can snapshot it and have all of the dependencies pre-installed. Most teams we see are having those images rebuilt every 30 minutes, and then when the agent starts its sandbox, it's then pulling down the latest changes. And so we're not starting from scratch. We already have the code pre-compiled. We already have all the dependencies and databases running. And so we can typically get that boot time around 2 to 3 seconds, but with the goal being under 10 seconds. As mentioned, a very big part of background agents is being able to access them where the work is already happening. A lot of the usage that I see teams today is Slack. It's becoming the kind of general interface for interacting with agents. There's a lot of benefits to this, especially if the system like OpenInspect is a multiplayer system where multiple people can be contributing to one session. And so maybe the PM is the one who started the session, looking deeper into how a system works, and then they hand off that session to the engineer, and the engineer can now jump into that session and deliver on top of it. Similarly, we're seeing a lot of use cases within GitHub where teams are using it to directly mention the agent and have it resolve everything from lint issues, addressing code comments from other reviewers, as well as merge conflicts. It's pretty exciting when you have access to the background agent system wherever you're working, and it unlocks a lot of pretty interesting workflows because since you own the system, you can integrate it into any of your existing systems. You can put it directly in the customer support queue where they're now able to access this without having to learn a new workflow or having to use a different tool. And so that's the general idea of the architecture that we see across most internal company systems. And so next we're going to transition into some of the issues that you're going to run into once you start deploying one of these systems. The first is that once you have background agents, it becomes very clear all of the gaps within your system. The first issue that you're going to run into is setting up that actual developer sandbox. Across the deployments that I've done with companies, this is almost always a pretty big friction point because the developer environments that they have currently are not actually reproducible. Most commonly, it involves manually modifying scripts, borrowing configuration from a teammate, getting access to a secret vault, and often the environment variables are not up to date, and so they're having to ask teammates. With the background agent, again, because we need that perfectly reproducible environment, you have to tackle all of these issues. But on a positive, once you have tackled them, that environment is perfectly reproducible. Another big issue that I see teams run into is around access control. In the world where your engineers are the one driving this directly from localhost, you can get away with less secure practices where maybe engineers have write to the system and we're using our good judgment to not modify production data. In the case of a background agent system, especially when non-engineers are going to be operating within the system, we need to make sure that we have very good access control because otherwise we're leaving it up to a prompt, which is not a secure boundary. And so, as mentioned, we see a lot of issues just where teams, it's the same process and the same pain point that a new hire has within the company, where they join the company and they spend a week setting up the developer environment just because it's so complex and it's not really well documented. I find that this issue is especially bad in companies who have many microservices, where often the developers, when they're running this locally, aren't even running the entire environment. They're connecting to the staging database and modifying it, and basically just hoping that they don't collide with their other teammate. The next issue that you are going to need to address is building custom tooling for the agent. While most of the systems that we interact with, whether that's our production logs or our database, they have APIs. These APIs are often complex and require many different parameters, which gives the agent ambiguity on how to actually interact with that system. As we iterate on these systems, we want to make it as reproducible as possible and as simple as possible. And so, as an example, the OpenSearch, which is a common tool that is used for logging for teams, the API for that has a significant number of fields, supporting everything from pagination to filtering and many other use cases. This then creates friction for the agent because, again, there's so many different parameters that they can choose from, and it just adds more complexity than otherwise needed. And so I see a lot of teams building custom tools for this, where they will wrap existing APIs and slim it down. Similarly, a pretty big benefit here is that because we control the input and the output of that tool, we can create streamlined responses for this. And so rather than a log loading and taking 70K tokens of our context, we can create a trimmed down log that is slimmed down to the information that we care about. Not only making the response smaller and more context optimized, but also more targeted and specific to our use cases. A issue that a lot of teams ask me about is, how do we drive adoption with this? Should we be mandating this? Should we just try to throw our entire backlog at this? What type of approach should we actually take to rolling the system out? I think the first thing that we see across all of these blog posts, as well as what I see in my customer engagements, is that using a system like this should be voluntary. We don't want to force our developers or non-developers to be using this because it will create friction. And so the goal here is that we should make the system obviously better than the experience that we have running locally. And what that comes down to really is basically bringing the system where work is already happening, whether that's in Slack, GitHub, Linear, if you guys are using Jira. The idea being that we don't want to keep shifting tabs or workflows to access this agent. We want the agent to be where we're already working. Similarly, a pretty good approach to this is running hackathons. I find that it is great for getting teams up to speed, where the teams get to experiment with the system, different use cases without a lot of friction or otherwise potential issues with this. Lastly, a great way to drive adoption is making it visible. I find that teams who are tracking the analytics of the system, whether that's through dashboards or counters, it creates kind of a fun competitive nature to the system. And it also helps identify who are the power users who can then help educate and drive adoption across others. As we are rolling this out, the guidance that I typically give teams is to start small. Start with small, well-scoped bugs so that you can learn the nuances of the background agent system, as well as figuring out any iterations or gaps that you currently have in your processes. And so the easiest way to do that is just to drive through your backlog, identify easy to fix bugs, and work through resolving them. As the teams gain confidence in using the system, we then see that larger tasks begin getting delegated. Most commonly, this starts where a team will be building the spec locally, but they can then start delegating parts of those. Potentially, they start with the simpler parts and eventually work their way up to the larger parts, and having that also running through the background agent system. The last phase is ongoing. We need the teams to continue iterating, building better tools as the use cases grow, and improving the system over time. A unexpectedly large use case that we see is non-engineers contributing code. And so most commonly, this is product managers and customer support. This commonly will create a lot of issues because they are not familiar with coding and general engineering. And so they don't know best practices themselves. And so a lot of that is then going to come back to the team on how do we build that quality control that we outlined earlier, such that anybody can be contributing code and we are maintaining quality. Most commonly, I see teams rolling out AI code reviewers for this, which are then tuned and iterated on over time, addressing CI issues, most commonly using semgrep to find kind of custom anti-patterns that they have within their code. And lastly, it's still engineering signing off on the issue. And so it shouldn't matter who is actually running the background agent system. We should have systems in place that ensure our quality. As the system grows, you're going to start running into issues. The number of pull requests are going to drastically increase. And this in itself creates a problem because we want to ensure that we're still maintaining quality on this. I don't think there's really a solved answer to this. I've seen teams experimenting with auto-approving pull requests based on the risk level. I've seen teams primarily relying on AI code reviewers, and if the AI code review passes, then the pull request can be merged. I think that this is an ongoing topic, and I think every company's use case is different depending on what environment they're operating in. But this is expected. You are going to run into a bottleneck where you are able to output more code than you can actually review. And so lastly, I wanted to cover a few lessons that I've learned just across the different deployments that I've seen that I think are valuable to teams. The first, the agent is only as good as your documented processes. Because the agent is starting a session fresh every time, the only context that exists is what you're writing down. Now, yes, you can hook this into your Jira or your Confluence, and it can gather that context, but it needs to be documented so that it's not starting from scratch every time. The second big lesson that I see teams experiencing is a misunderstanding of what it means to deploy an AI-based system. An AI-based system is very different than a traditional engineering system because it requires constant iteration. As more users and more use cases run through the system, it requires continuous iteration to ensure that we are correctly addressing those use cases. This might mean new tools, new skills, new hooks, but teams should expect that this is not a one and done system, that they are going to need to continue to iterate. Along the same line, the final lesson is that plan for the increase in operational load. As we make these background agents available across the company, the team that is responsible for managing this is going to come under increasing load. The initial set of tools and use cases that they plan for is no longer the use cases within the system. And so it requires us to address that. And we need to plan ahead of time to make sure that that team is properly staffed so that we can properly scale the company system. Last, I think the frame that I'd like to leave you with is just that the agent is a perpetual new hire. As anything changes within your company, it will begin with a new, fresh session each time. It doesn't know how certain things work. Yes, it can find them out, but it really comes down to you and your team on correctly documenting and building a system around this. With that, thank you. The project is open source. You can fork it, customize it, and tell me what broke. Tell me some of the cool learnings that you've had as you deploy it, and some of the challenges that you run into. You can find the project on GitHub at Background Agents. You can find more about me and some of my writings on my personal website, as well as reach out on x.com. Thank you so much.